Hi, welcome to the video on the US Customary Measurement System. This is very similar to the metric system as far as the lesson goes, just the numbers are a little bit different. Alright, so the US Customary System is obviously the system of measurement that is used in the United States. It's similar to the British Imperial System, which is basically what they use almost everywhere else besides the United States of measurement, but it's not necessarily the same. It involves same type of things that we're going to talk about. We're going to talk about length units and really maybe just time, but these are the ones right here that we're going to be talking the most about. Okay, so same as before, common size comparison, just kind of showing you that as the number increases, obviously the diameter or the thickness of something increases, just to kind of show you exactly what the differences are between those. Just a little visual for you. Okay, so again, a repeat pretty much of what we had already talked about. A measurement always includes units, and there's always going to be some sort of an error, right? Because a measurement is always just the best estimate of a quantity, and then we're going to use the significant digits like we talked about in the other video, and then we're going to talk about something called accuracy and precision. All right, so precision is repeatability, the degree to which repeated measurements show the same result, which means if you do the same thing, you're getting the same result. Accuracy is the degree of closeness of a measurement of a quantity to the actual or accepted value. So there's a little bit of a difference. If you look here at the charts, this first one has high accuracy and low precision, whereas this one has low accuracy and high precision, and this one's got both high accuracy and high precision. Okay, because basically if you're shooting at a bullseye, your goal is to get here in the center, right? So the easiest thing for me to do is to go ahead and start with this one. It's high accuracy because it is in the middle, right? And it's high precision because they're almost all clustered together, okay? Whereas this one, right, these are both high precision because they're grouped together, right? This one's grouped together and that one's grouped together, so that makes the high precision, but it's low accuracy because it is not in the bullseye, okay? Now this one gives you high accuracy because it's really close to the bullseye, okay? But low precision because they're not grouped together, they're kind of spread apart. So you just kind of have to understand that there's a difference between accuracy and precision. Okay, so ideally you want a measurement that is both accurate and precise. Okay, accuracy is dependent on the calibration to a standard, and precision is dependent on the characteristics or capabilities of the measuring device and its use. Okay, so basically that means that if you're using something to measure like a scale, it has to be calibrated correctly, which means that it has to be set to where the measurements are all going to be the same. And the precision is how you actually read that measuring device. Okay, so we talked about significant digits, right? Basically, you're always going to have an uncertainty about your measurement, okay? So you're always going to record your certain digits, and then you're going to have a decimal number that is telling you what the uncertainty of that quantity is. Okay, and again, same thing, digital instruments, you're going to record all the numbers, including zero, exactly as displayed. And this right here is what we're going to use. We'll use decimal scaled instruments like rulers, calipers, and protractors. And when you're talking about the U.S. standard system, a customary system, in inches and things like that, it's actually scaled as a fraction and not decimals. So we're going to be talking about that. Okay, so look at the ruler. Rulers are typically 12 inches long, 1 foot long, and each inch is graduated into smaller divisions. So graduated means that it's going into smaller divisions, and typically they're 1/16 of an inch increments. That just means that if you count all of those little ticks there, every single one of them, you will have 16 1/16. Okay, so there are 16 1/16 in that ruler, basically what it's saying. All right, so this is how it's marked on the ruler. The first thing, the largest one, is the inch, obviously, so the distance from here, the distance from here to here is 1 inch. Okay, so here they have a half mark, so that just means that the distance from here to here is 1/2 inch, and the distance from here to here is 1/2 inch. Now on math, just to kind of give you a review, if you want to take a half of a half, so that'd be the half times 1/2 equals 1/4. So our next increment is in 1/4. So there's 1, 2, 3, 4. And after 1/4, you multiply that because you want to know what is a half of 1/4. So we're talking about which measurements are going to be in between here. 1/2 times 1/4 is 1/8. So the next increment is going to be 1/8. Okay, so that means that there's 8 of these. 1, then there's 2, 3, 4, 5, 6, 7, 8, and that gives you a whole. And if we're looking for the ones halfway in between, it would be 1/8 times 1/2, which is 1/16. That's going to be our next increment. And that's what we had talked about, that there are 16 1/16ths from here to here. And if we were going to figure out what is halfway in between there, 1/16 times 1/2 is 1/32. And you can keep on going. Typically, you're going to go to like the 16th or maybe the 32nd, just kind of depending upon what your measurement is. Okay, so let's go ahead and look at this rectangle. We'll talk about how to figure how to do this. So the first thing you want to do is you want to look at the fact that it does go to 2 inches. So we're going to know that it's at least 2 inches. We know that for sure. And then it's going to be something else besides that. All right, so what I would do is I would start looking at my rectangle. You can tell that it goes over the eighths, right? So this is 1/8. I'm sorry, 16ths. This is 1/16. That's 2/16. Now it hangs over, so if it's halfway in between 2/16 and 3/16, which is right here, we're going to say that these are now going to be 30 seconds. Remember, if we go through our list. All right, so that means that this is a 16th, that's a 16th, sorry, a 32nd, that's a 32nd. So if I go through and I count those, it's going to be 1, 2, 3, 4, 5. So that means that it's 2 and 5/32 of an inch. Okay, so you just have to keep on going. And what I would make sure I remember is that the way that rulers go is it would be obviously whole feet, then half, then fourth, then eighths, then 16ths, then 32nds, and if you have to go another one, it would be 64ths. We probably won't use 64ths a lot, but if you kind of understand that these are your increments in inches, it'll be much, much easier. Okay, so if we're using the fractional scale, right, we talked about that it's 2 and 5/32 of an inch. Okay, so if you wanted to change that to a decimal, you would have to take this number, 5/32, and 5/32 is the same thing as 5 divided by 32. So if you put that into a calculator, you would get this number right here. Okay, and then it's asking you, is 6 significant digits appropriate? Do you want a number that is this long? Right, and basically what it's telling you is no, you want to go ahead and round it to the nearest hundredths of an inch. Okay, so again, when you're talking about precision, you know that it's more than a 16th, but less than something else. So that's why you would pick the 16ths. All right, so now you're going to do the same thing you did in the last activity. You're going to set up a table and put the measurement for each of these rectangles, being careful to get as exact and precise as possible. All right, thanks. You guys have a good night.